Imagine a tiny spacecraft, no larger than a small car, drifting in the unimaginable blackness beyond our solar system. Its faint signal, traveling across billions of kilometers, whispers back to Earth, a message from the frontier of human exploration. This is Voyager 1. Launched in 1977, its twin, Voyager 2, followed a similar path. Together, these two robotic emissaries have become the furthest-reaching human-made objects in history, crossing boundaries no other spacecraft has dared approach. The story of Voyager is one of ambition, precision, and cosmic curiosity. In 1979, both Voyagers swept past the giant planet Jupiter, sending home stunning images of its swirling clouds and volcanic moons. A few years later, Saturn's majestic rings revealed their secrets to Voyager's cameras. Voyager 2 pressed on, alone, to Uranus and Neptune, unveiling mysteries of the outer planets that had never before been seen. Decades later, these spacecraft are still out there, escaping the sun's grasp at incredible speeds. Voyager 1 at 11 miles per second, Voyager 2 at 10 miles per second, steadily widening the gap between themselves and home. But what lies ahead for these explorers as they venture ever deeper into the unknown? Beyond the planets, past the Kuiper Belt with its icy remnants, a new and enigmatic region awaits: the Oort cloud. Predicted by Dutch astronomer Jan Hendrik Oort in 1950, this vast shell of icy bodies is believed to surround our solar system like a cosmic cocoon. Though we have never seen the Oort cloud directly, the evidence for its existence is compelling. Many of the long-period comets that sweep through our skies are thought to have originated there, nudged inward by distant gravitational tugs. The Oort cloud begins an astonishing 10,000 astronomical units from the Sun. That's 10,000 times the distance between the Earth and our star, or about 930 billion miles. And it may extend out to a staggering 100,000 astronomical units, nearly halfway to the closest neighboring star, Proxima Centauri. If the Sun and its planets were a tiny dot in the center of a vast sphere, the Oort cloud would be that sphere's invisible icy shell, so distant that light from the Sun takes more than a year to reach its outskirts. So, what exactly is the Oort cloud made of? Scientists estimate it could contain some 100 billion comet-sized objects, each roughly 6 miles in radius, icy leftovers from the birth of the solar system, preserved in the deep freeze of interstellar space. The combined mass of these objects might be about the same as Earth's. Yet despite the staggering number, the Oort cloud is so vast that these bodies are separated by enormous distances. If you could somehow gather every Oort cloud comet and spread them out over the Sun's surface, they would form a thin, scattered layer, an almost invisible veil. This brings us back to Voyager. As these spacecraft hurtle through the void, will they face danger from the Oort cloud? Could a collision with one of these icy wanderers spell the end of their journey? To answer this, we need to grasp just how empty the Oort cloud truly is. Imagine the Los Angeles Reservoir, which in 2015 was filled with 96 million black styrofoam balls to prevent evaporation. Now picture scattering those balls across the entire surface of the Earth. The chance of finding one in your own backyard would be staggeringly small. Yet, even this is generous compared to the odds facing Voyager. The probability of it hitting a comet in the Oort cloud is at least 100,000 times less likely than picking out that single styrofoam ball. The numbers are almost beyond comprehension. Spread over a sphere with a radius of 10,000 astronomical units, the average distance between comets is so great that Voyager could travel for thousands of years without ever coming close to one. Even the surface area covered by all 100 billion comets, if you could flatten them out at the Oort cloud's distance, would be reduced by a factor of 1 in 10 trillion. The vastness of space, it turns out, is a remarkable shield. Voyager 1, currently almost 168 astronomical units from the Sun, and Voyager 2, not far behind, are still centuries away from even reaching the inner boundary of the Oort cloud. At their current speeds, it will take roughly 300 years for either spacecraft to approach this distant realm. And even then, the Oort cloud is not a solid wall, but a diffuse haze, one so tenuous that the chances of a spacecraft colliding with a comet are less than the odds of winning the grandest lottery on Earth. Yet, despite these odds, the prospect of our spacecraft entering the Oort cloud is awe-inspiring. These icy sentinels, untouched for billions of years, hold the secrets of the early solar system. They are time capsules from the dawn of planetary formation, preserved in darkness at the solar system's edge. While Voyager's journey is unlikely to be cut short by a cometary collision, its passage marks humanity's first tentative step toward interstellar exploration. Even as the Voyager's power sources fade and their signals dim, the spacecraft themselves will continue to drift silently onward, ambassadors of Earth, bearing a golden record of our civilization into the cosmic ocean. The Oort cloud, though invisible, is a testament to the scale and wonder of our solar system. It is a boundary not just of the sun's gravity, but of our knowledge, a frontier that beckons with the promise of discovery. As Voyager glides ever outward, it reminds us that the universe is far vaster and filled with more mysteries than we can possibly imagine. And somewhere beyond the known planets, in a realm of frozen relics and ancient comets, humanity's explorers are quietly passing by, undaunted by the darkness, journeying into a future that lies among the stars. The true scale of the Voyager's ongoing journey becomes clear when we consider the vast distances and timescales involved. Right now, Voyager 1 is racing away from the Sun at about 11 miles per second, an astonishing velocity by any earthly standard, but still, at this relentless pace, it will take nearly 300 more years before it even reaches the inner edge of the Oort cloud. Voyager 2, just a bit slower, trails behind. Even then, crossing the width of the Oort cloud could consume tens of thousands of years. These are timelines that vastly exceed the operational lifespans of any spacecraft and even the entire span of human civilization so far. The Oort cloud itself remains one of the most mysterious structures in our solar system. First hypothesized in 1950 by John Oort, it is a theoretical shell of icy bodies, a colossal bubble encompassing the Sun and planets, stretching from about 10,000 to 100,000 astronomical units from the Sun. For context, 1 astronomical unit is the distance from the Earth to the Sun, about 93 million miles. The Oort cloud's outer boundary is so far that the nearest star, Proxima Centauri, is only about 3 times farther away. This immense region is thought to contain up to 100 billion comet-sized objects, and yet, despite the staggering number, the Oort cloud is almost incomprehensibly sparse. Imagine spreading those 100 billion icy comets across the entire volume of the cloud. Each would be separated from its neighbors by vast gulfs of empty space, far greater than the distance between planets in the main part of the solar system. So, what does this mean for the fate of the Voyager spacecraft as they venture into this distant realm? Could these ancient robotic explorers be struck by a comet or damaged by debris? The odds are, quite literally, astronomical. Calculations show that the probability of a Voyager spacecraft colliding with even a single Oort cloud